VTVM repair adventure. Join me in the fun, won't you? Look at the size of the meter. So this is a standard DMM compared to the meter face on this VTVM. So it's not only good for your workbench, but your neighbors can see it too. I'll also take you through the calibration procedure as I go through and align this thing. Let's get started. To get inside the VTVM, I need to remove the screws around the face of the unit. There are no screws on the back side. I'll just move the back side out of the way, get this turned around so we can take a closer look at the circuitry inside this VTVM. As you can see, the inside of this VTVM is relatively clean, and that's because the case itself has no vent holes. So if you find an old VTVM like this that has a case that's sealed, chances are it's going to look relatively good inside. There's another reason for that as well. This has to come up to temperature. So this doesn't create enough heat to, be affected by being in a sealed case, but it has to come up to temperature in order to stabilize and to be relatively accurate. Now, when I say relatively accurate, that's, a relatively loose term. We're not looking for pinpoint accuracy out of a meter here that's, half the size of a house window. So I'm looking for, just relative accuracy out of something like this. It's great for peaking IF sections and, just doing random work on the bench. Again, something that's not requiring pinpoint accuracy. In order to make this thing dependable, I have to get rid of the capacitors in this, and not all of them, but most of them. So this one has to go, this will have to go, this will have to go. The electrolytic, that's the filter for the power supply, will have to go. And this should be unhooked and a new cap installed on the back side, especially if these adjustments are made. I'll talk more about that and the safety about that here throughout this video. So there's two adjustments here for the alignment. On the bottom side, there's another capacitor that has to go here. There are another two adjustments for the alignment right here. You can see those two adjustments. This capacitor here can stay. Again, this is a domino style capacitor, so that'll be okay. And there's one more adjustment on the back side here, which is for the current range. Now, before any alignment is done in anything like this, it's very important to use some contact cleaner in all of the switches and cycle the switches a bunch of times. If you don't do that, chances are your results will be sporadic. Now, these tarnish over time and the contacts do become slightly resistive. So it takes just a short amount of time just to give it a burst of contact cleaner and cycle it a few times, and the difference is night and day in your results. A lot of the times you'll find the meter doesn't read accurate in a bunch of scales, and again, it's just because the contacts are tarnished and have become slightly resistive. So I'll talk all about that, and I'll show you exactly what I do in that procedure as well. So to get started, I'm going to replace these caps here, and I'll show you how I'm going to replace this, and we'll move on from there. This capacitor looks like a Hunt's device. I'll find out in a moment. Hey, look, it says TNT on it. Is that not appropriate? Some sort of sick, twisted sense of humor they had at the factory when they put these things together because they could tell the future. Makes you wonder, doesn't it? So as I talked about before, I always clip the ear on these. What they do is they wrap the post around. You can see this little wire they've wrapped around the post here. So what you do is just clip the end of it off like so. And then if you heat it, it should just come loose. Now, I should have been a little bit more prepared here and grabbed a pair of pliers. I'll just use these to pull the thing out. Now, I'll just clip it out then. It's now loose in there. So anyways, I didn't have a pair of pliers here. I thought I had a pair of pliers on the bench. Is it a Hunt's device? Oh, it is. So there we go. British made Hunt's capacitor. So it says inside mark. I think. No, trademark, it says. A51. So 0.1 at 400 volts is that one right there. So what I need to do is go grab a pair of pliers, which I thought I had on the bench here. So there's that little piece. It can just fall down there. And I'll just vacuum that hole out again. And that makes it nice and clean for the new one. Again, I don't like to do the, it's called a J-hooking method. So yeah, they don't, I really don't like that method. It just doesn't look very clean, that's all. So I'll get a head start on this and then go grab the, see where the ear is on that one. It's over there. All right, I can probably just clip this one and maybe even just take it out without a pair of pliers. Let's see if I can, it's gonna allow me to do this. Hopefully I'm not blocking everything so you can see this. All right, let's see. There we go. So there it is. Focus is set here. Let me put this down. So there it is, 0.1, Hunts, British made. That is, that's classy right there. So very appropriate for these capacitors. So what I'll do is I'll get another one of these and install it. Of course, a much better device than what I've got in my hands. All right, let's see how accurate Hunts was with the outside foil end of the capacitor here. Sometimes they weren't so accurate. Companies, I'm not sure how accurate Hunts was. Let's see it here. So the minimum amount of LEDs lit will indicate the outside foil. This should be the outside foil. So the minimum amount of LEDs should be lit at that point there. So I'll just put this up like this. Hopefully you can see this. All right, let's see what happens. Here we go. Yes, so they did mark the right side. So you can see minimum amount of lights lit, right? So not bad. I've already marked the outside foil on this new cap here, so I'll put it in the correct way that they had it installed. The newer caps, they don't mark the outside foil on them just because most of these things are on printed circuit boards and they have a ground plane layer underneath. So you can see on this one here, if you look at the LEDs down there, you can see, so minimum amount of lights is this LED on this side here, which would mean that this is the outside foil here on this one side. And as you can see, I've already marked that side, put a little dot on it. You can see that okay. So that will go into circuit just the way they had put this in. I'll put that back in there, and that's one cap replaced. I'm going to replace this electrolytic capacitor here, and I'm going to mount the new one right down in this area right here. This is the ground lug right here. Now this ground is isolated from the chassis. So this ground connects to the capacitor that I just soldered in, and of course that wire that I just removed connected to the ground of this capacitor, and that all connects to this terminal right here. So I can comfortably use that as the ground. Now I need another area to tie the positive portion of this cap to, and this lug on the tube socket is unused. Now, before any lug on any tube socket is repurposed or used, the datasheet needs to be looked at to verify that there is no internal connection or internal shield attached to that unused pin. In some cases where the B+ levels are very high, they'll actually leave a space between the two plates. So you'll see the plate, and then you'll see this space here, this unused lug, right? That unused lug right there. And then there's the other plate. The reason that they leave that unpopulated is to prevent arc over really in the tube socket. So you'll notice in a lot of octal sockets between the two plates there actually is no lug at all. Now the reason that this one is left in here is because the B+ levels in this unit are so incredibly low that it wouldn't really be too much of a big deal. But if the B+ levels were high, used in a different circuit, say the 6X5 was in a television or something like that, and there was high B+ between the two areas here, remember that the AC between this and the ground is double, right? Because this is a full wave configuration. So if the B+ from here to the chassis was say 100, from here to here it would be 200, right? It would be double. So whatever it is from the actual ground, again, the ground on this unit is isolated from the chassis, but this from this to the center tap, right? From here to here would be double, right? And that's the reason, again, that they get rid of this one pin in a lot of applications. This pin here, again, is unused. There's no actual pin on the other side that comes out of the tube. Is a blank spot there. So this is completely fine. So what I'm going to do is I'm going to run the cathode of this tube over to this point. So the cathode is what's attached to the center terminal on this capacitor. I'll run the cathode over to here, and the new capacitor will just sit in this area from here to here like so, and it can be left like that. So that is the next step. If the solder is stubborn and it doesn't want to melt, in this case I've given it enough time here. A lot of the times you can add solder. If you add solder, it makes a thermal connection quite a bit quicker. So that's just another solution if you know, if it takes too long to, say, the actual tip of the iron isn't melting the solder there. So that's just another solution to something like that. So I can see a bit of a hole in the bottom here that could possibly poke this through, but it does look like it's going to be a slight bit stubborn. So what I'll do is I'll grab one of these tools out of my toolkit here that has a bit of a pick on the end of it, and what I'll do is being very careful with my finger, right? The pick is lower than my finger. I'll just try and poke that through there, and what that does is it allows the hole to be elongated just a little bit, and a lot of the times that helps out. In this case, I don't know if it is going to though, because I think there might be something sitting in front of it. Yeah, there is. There's something sitting in front of that, or it's just going to be stubborn. So another solution is to actually heat the tab itself. There's a lot of connections on here. To heat the tab itself, these are very flexible tabs. Most of them won't pull away from the tie strip like this, but just heat the tab and then try and poke the tool through, and a lot of the times you can make a decent hole in the bottom there. So there's a bit of a hole in the bottom now, and it won't stick to the tool, right? So that allows for easier access. So now that that's done, it should be cool enough for me to bend back up. And then what I want to do is use a thing called lead dress. So I'll put a little bit of lead dress on this capacitor here. So I'll just cut it to a size that I think will leave me enough area to solder. I'll slip the lead dress on the capacitor, and just because it's floating in kind of midair like so. And then I can see on this side here I'll be relatively close. So I'll do the same. I usually measure it up. I don't like to waste this stuff, right? So put this on here like so and kind of size it up and see it'll, be relatively close. Put that there like so. And that looks like it should be pretty good. So I'll put this in here on this side, get that in there, and put this on that side like so. Now what I'm going to do is I'm just going to tack this into place for now. I want to make sure that at least this is going to be held as I'm joining wires in here. So I'll add a little bit of solder right here. And often what I'll do is if it's not exactly in the right spot, that's holding pretty good. I can slide it just a little bit and just hold it because I'll go over and I'll retouch up the solder here in just a moment. I could actually give it just a little bit more. This is quite a bit of lead through this one side right there. Again, there isn't a whole lot of lead to spare. They cut the leads on these newer capacitors relatively short. So that's that. So now when I work on this side here, after I solder this side up, I'll go back and just touch up this side, and that'll get the new cap in. So this is the old lead right here that'll run up to the old capacitor. So I can just get rid of that because the capacitor is just going to sit there and not do anything. This lead runs over to the tube socket over here. Kind of runs around. I don't know if there's going to be enough room to get this. Yeah, there will be. So I don't even need to add a new lead. So what I'll do is I'll give myself a bit of room here, right there. And I'll put a bit of lead dress on this as well. If it's too long, I'll just trim it up. Sometimes it's hard to get that exactly right when it's in the tube socket itself. No, that's okay. That'll work out just fine. Grab the pair of pliers that I should have had in the beginning. Put this through here. I want to make sure that I don't poke the filament lead, so I'll just move this out of the way. Put that in there like so, and add some solder to that. Now I talk about using flux sometimes for the more stubborn connections, so RA type flux is a really good solution. If that is, if the connections themselves, see the plating is still really good on this, so it's taking solder quite well. So there it is. So that right there is the new filter capacitor installed into the circuit, and it completely disconnects this one here. There are some differences between the Stark and the Hickok schematic here. This is the Hickok schematic, and because there really is very little information on these things. So the Hickok 209 is virtually identical to this. You'll notice that if you're working on this, these two pins will be interchanged. So this will be 5 and this will be 3. It doesn't really matter, but that might be confusing for some of you if you have one of these and you're actually trying to restore this. So they've just interchanged the plates. So pin 5 goes over to this cap, which is this cap right here. And as we can see, that's pin number 5. So you count from the index pin clockwise, and that gives you your count. A lot of the times if you look on the base of the tube, you'll actually see 1, 2, 3, 4, 5. They've actually numbered them to make things even easier. So this is the next cap that has to go. It looks as though somebody has replaced this over time. I can see that the solder joints here are relatively fresh. Yeah, the whole top of that tube socket came right off there. So I guess that would indicate how fresh it actually is, right? Somebody's been in here and tampered with this. So this cap here is definitely underrated. So this cap is running up to the measurement post on the front of the unit that's designed to measure 1200, and they've put a 400 volt cap in here. So this is common, these are the kind of things that are found when stuff like this is just worked on. It's always a good idea to go through this stuff, right? They wrapped that around that post actually pretty good. So there we go. So that's out of there. And so the new cap will go from here to here. I'm going to have to find a new cap and repair that area of the tube socket because somebody has actually broken this off and soldered it to this. Now many of you may be asking, Paul, you're soldering that tube lug with the tube socket in there. Yes, I am, because it's absolutely fine to do that. So unless you're heating the actual unit to temperatures unknown to man, it's absolutely fine. You don't need to pull the tube out. If you want, you can if you feel more comfortable, but I've done this and I've never actually had a problem, ever. So, and I've soldered a few tube sockets in my time. So anyways, there it is. I will get a new cap and install it from this point to this point and make sure that it exceeds the actual rating of where this connects to, which is 1200. New capacitor installed. So this is going to be pretty tight to the back case here. So I bent some of the tabs over and I pressed it down in just a little bit more so that there is clearance. So I measured from the inside of the case here to the top portion of the cap, and then of course measured inside the actual case itself. So from, you know, here up to this lip right here. And I should have just a touch of clearance. So something to keep in mind whenever larger components are put into place. Everything is soldered in. Looks like there's a hole in the solder there, but there isn't. That's just a shadow. Look at that. Looks like there's a hole under it. That's the thing with reflective surfaces, right? Can make soldering connections look very deceiving. So anyways, this is done. The next one is this wax cap down in here. If I haven't mentioned it, this is for the batteries for the ohm meter in here. So this will require some D-cells before the end of this restoration. So let's see this cap here. Looks like this is soldered on the bottom there. It is. So I'll just desolder this. And clip that. You can see that there. And move this out of the way like so. And heat that up and pull that cap through. There it is. Carefully without trimming the terminal. There it is. And it's always nice to try and see if we can pull that right out like that. So, another slimy capacitor. What's the rating of this one? 0.047. Same deal. Now before I solder this end here, this is a capacitor that's running from the line actually to the chassis, and there is no 3-wire cord in this. So in order to increase the safety, I want to replace this capacitor here with an X1Y2 rated safety cap from the line to the chassis. Now this is going to be on the neutral side anyways. This is the switch side over here, but I'm still going to replace this with a X1Y2 rated cap. So I'll just move this around. Should probably be able to pull that out, in fact. Just heat that up and it should come out even with the new cap in the terminal there. So the terminal tie strip. So just remove that. Just touch this and it'll probably come right out like so. The new line cord is fed through the grommet in the back side of the case, and it's here ready to be installed. To enhance the safety of this unit even more, I want to add an inline fuse. And not only does it enhance safety, but it also protects the power transformer in this just in case something was to go wrong. So the fuse holder will go right here. There's a lot of space between here and the back side of the case. So that's a good place to mount this and it won't interfere with anything. The power cord comes in about this area right here through the back side of the case. So the hot lead will run up to here and the neutral down to here. I'll run the hot lead from the other side of the fuse holder back over to this area over here. So that should work out really well. So I'm going to get a hole drilled for this, mount this onto this, and we'll move on. X1Y2 rated safety cap installed, new line cord installed, along with a fuse holder and a fuse for added safety, and of course to protect the transformer. And there still is one capacitor hiding in here, right down in there across the meter. So that's the next capacitor I'll replace. Old cap, new cap, quite a size difference there. So again, I'll add just a little bit of lead dress to this. So it's not really too incredibly important. It's a really low voltage application, but it just kind of fits. So you know what they say, if the shoe fits. I'll put that on like so, leaving just a little bit exposed on the end. And I'll do the same for this side here. And that should make it okay. So I'll bend the ends. It also helps keep the lead dress on so it doesn't slide around. At the end, just a little bit of a bend there. And a little bit of a bend there. And that way the lead dress doesn't fall off, which is kind of nice as well. Put that in there, that in there. And I'm going to, the reason I bent the tabs down like this is so I can get the protection diodes in there. In a little while, I'm sure that other meter that I was telling you about, the one that's identical to this, could have used that. That's probably why the meter is toast, because it didn't have any protection. And usually what ends up happening, what actually destroys the meter, is somebody's fiddling around in here and they touch a screwdriver to the wrong points or something like that. And you know, applies a lot more voltage to that meter than it's supposed to deal with. And then they're just done. So. Right, these are very sensitive meters, and most of them are, right? So there it is. Really can't see it too well, but there's the cap. Right there, installed across the meter. Just like that. So that's it. I can put the tubes back in, ones that I'm not supposed to be touching the glass on. So just so you know, I'll repeat it again in this video. As long as the tube is cold and the circuit is discharged, touching the glass of a vacuum tube is completely fine. It's not like the glass that you'd find on a headlight, one of those quartz halogen type headlights. This is a soft glass. So the worst that's going to happen is you're going to rub the numbers off or leave your fingerprint on it. That's pretty much all that's going to happen with a vacuum tube. Now there's, of course, hard glass vacuum tubes as well. This is a soft glass vacuum tube, but the hard glass ones are basically used in transmitting service, things like that. So this is basically the same type of glass that you would find in a standard drinking glass, something like that, right? So, okay, what I'm going to do is give this a shake. It's always very important to do. Give it a couple of taps, get rid of any of the loose endings, little pieces of solder floating around in the circuit. And yeah, should be good. I haven't added the batteries yet. I'll check the ohms and all that kind of stuff later on. But we'll get some power applied to this thing and let's see if it actually does anything. All right, the moment of truth is here. I will turn on the isolation transformer and current limited variac supply over here. So it's in current limit. And let's turn this on. Should be a dim glow. Nothing is turned on yet. So I'll turn this on. So what I'm going to do is flick the switch on the front here. So we'll see what happens with those bulbs. If they glow very bright, there's an issue. But if they get just a little brighter, there's no problem. So let's see, keep an eye on those two bulbs at the top. Here we go. That's looking really good. No problems there. So the next thing is to see what happens here, and that's about normal. It should start doing that. Move up and down, and then usually settle off, or not. That's what the zero adjust is for. So that's what this is for. So everything is all over the place on this, right? And of course it's cold and everything needs to warm up. So it's being limited out by the bulbs. So there's reduced current being applied to this thing right now. So what I'm going to do is I'm just going to flip the bridge switch right here. That's that switch right there. And it'll bypass the bulbs and it'll give this thing basically full line through the isolation transformer and current limited variac supply. So here we go. Bridged out. Now the tubes will actually warm up properly. So this will move until the tubes come into emission properly and everything in the circuit actually stabilizes. So this would be brought down to this point here. Of course, being zeroed, in a normal application it would stay on the zero, because it's warm, but it has just been turned on. So right now it's on AC volts, which means that this probe, yeah, there you go, it should be relatively sensitive, and that's working. So this probe here, see how big that probe is? Not huge. You know why? There's a tube inside here. So there's a vacuum tube inside there. So not only do you have a nice AC probe, but if your area, your lab, your shack is cold, this will warm your hands up in the wintertime. It's kind of nice. You can hold on to this nice warm probe. The unit is off and I've sprayed the switches down with a whole bunch of contact cleaner, and basically what I'm doing is just that and this and then that and then this over and over again, and just making sure that the contacts are clean and the oxidization is gone. Do it the same with the bottom one. This, and then move it around a whole lot, give it some more and keep moving it, and just get rid of all the oxidization in the contact area of the switches. You'll notice that some of the other areas of the switch may still remain a little oxidized, but the parts that are actually moving in and out of each other, the parts that are coming in contact with one another, it cleans the oxidization right off. So basically in these switches there's little fingers that sit like this, and when you're moving it back and forth, these little contacts move in and out of the switches. And the area that's rubbing, this cleans right up, and it's the same. It'll put an actual little track if there's any oxidization on the rotor part of the switch as well. So it's a very needed thing to do before any alignment is done. I'm also going to spray inside the potentiometers, but I will spray inside these and move these back and forth, and I'll go through that again and just clean everything up. That way, once the alignment is done, it should be good for a very long time. So before I go about powering this thing up again, of course, all the overspray and everything will be wiped off of everything, and it should be ready to go. The very first step in the alignment procedure is to mechanically zero this needle on the zero line. So no power is applied to the meter when this is done. The meter needs to be sitting in its upright position, so the way it would be sitting in the cabinet on the bench. It can't be laying on its back or on its side. It has to be in its normal operating position. This adjustment here is moved around until the needle sits right on the zero line. Very important first step. If that step is not done first, the entire alignment that you see after this step is invalid. So it's absolutely crucial to do this step first. I'm now ready to perform the alignment on this. So everything has been cleaned in here and basically all the adjustments have been moved inside. So it's definitely going to need an alignment. So the very first thing to do is have the unit on DC volts and then ground the DC probe first of all. And let's put that ground there like so. And then what I'll do is I will also run a ground from this over to the AC probe. So just everything is grounded. So this is the AC probe. And it's nice and warm. It's been on the bench for a while. So I've let this warm up for just a little while. It's about as warm as it's going to get in open air, being outside of the case. So now, the very first thing I want to do, DC volts, and this really doesn't matter right now, but on DC volts, I want to zero this. So I want to put this on the 0 mark. So I'm going to look at this straight on again. So that's right on the 0. That's looking at this straight on. Now what I'm going to do is go to AC volts. And now I need to zero this. So again, it's on normal. So that's these two adjustments here. So this is normal and this is peak to peak. Again, this capacitor is unhooked. So I'll move this and zero this one. And that is right on the 0 right there. And now I will go to peak and adjust the other one, which is this further out one right here. And that's pretty much right there. Right there. So now, when I go to DC volts, should hardly move. So I'll go back to this. We should see it barely move, and to normal, barely move. So very, very close. So I'll go from there to here. Yep, right on the 0 and to DC volts. So that's all done. So that's those two adjustments completed. So the next two adjustments are going to be to adjust the actual DC volt scale and the AC volt scale. So I'll get that all set up and I'll be right back. I'm now about to align the DC volts on this. And again, this is a factory calibrated device and they really didn't make the adjustments too incredibly easy to get at. They put them on the bottom, which is absolutely silly. The adjustments should all be on the top so that you don't have to move the device around. You don't have to move the VTVM. You can just adjust everything on the top and everything stays steady. But again, back in the day, this was their thing. They wanted you to send the thing back and they would do the job basically. So they probably had a special jig that sat up high with something that they would poke into the bottom of this. So anyways, the unit itself is heavy and it has to be tipped on its side to be adjusted and then put back down and then read. And then if it's still out of adjustment, tipped back up and then a little bit of a tweak and then put back down. So it's a little bit of a back and forth procedure here, but I'll show you exactly what I'm going to do here. So DC volts, the circuit switches on DC volts. The range switch is on the lowest range just as before. Everything needs to be zeroed, so check the 0. If it's not zeroed, it needs to be zeroed. And the function switch really doesn't matter because we're on DC, but I'll just leave it in normal. So this can be set with just a standard power supply. So if you have a power supply, set the power supply to say 1.5 or 2 volts and align the scale to that. So I have mine set at 2 right now. So what I'll do is I'll just turn this on. And I want to align the needle now so that it reads 2 volts. So now what I'm going to do is I'm going to tip this up, being very careful with my hand, just touching the corner of the chassis here. The DC alignment point is right there. So this is the DC alignment point and this is the AC alignment point. So AC is closer to the front, DC is closer to the back. So what I want to do is just move this down, and I'm going to have to tip this back up again because of course, you know, all the weight of the needle and everything is going to cause some inaccuracy because it's on its side. Again, they probably had a jig to do this. So I'll get it as close to 2 as I can. Maybe I'll leave it a little over 2. And Yeah, right about there, and we'll see what happens. Right, so I'll flip this back up, being very careful of my hands, and I'll watch that and see where it sits. So to my eyes, it's just a little bit above 2. To yours, it's probably close, but it's just a little bit above. So what I'll do is I'll move this back over here again, like so, and bring that down just a touch. Hopefully you can see this okay. Just like so. Move this back up, being very careful of my hands. And very, very close. Again, I could probably make that just a touch better on my end. So I'll just give that just a squeak and see what happens. All right, that's right on 2. All right, so now in order to check the accuracy, I'll go down to 1 volt. All right, so I'll go down to 1. And that is very, very close. You know, a little bit below, just a touch below. So I'll try it at 3 volts. And that's spot on 3. So that's right spot on 3. So I'll try 1.5 just for the fun of it. So I'll go. And that is so incredibly close to 1.5. You know, it's, again, we're splitting needles right here. So what I can do is, just for the fun of it, I'll try to bring this right up to 1.5, and we'll see how it tracks at 1.5. So again, I'll just be adjusting this DC control on the back here up just a touch, like so, and see what happens. All right, that's sitting right on 1.5 on my end. I don't know if I can get that so that it's like facing you. Now keep in mind that even rocking this back and forth, as you can see, will adjust the needle just a touch. So that is actually just about a needle, maybe a needle low. Not even half a needle's width low on my side here. So we'll see how that tracks first. Okay, so I'll go back to, say, I'll try 2.5 volts. That's as easy as a click. And that's sitting right on 2.5. Okay, so now what I'll do is I'll go down to 1 volt and see how that tracks. And that's like a needle. Can you see that? I don't know. So very, very close. Very, very close to 1 volt. Now, of course, since I adjusted this up here, I want to see what it's going to look like at 3 volts. So does it go over the end or not? And you see that's just a touch over 3. So that's about the right area to adjust it. And it just turns out to be that 1.5 seemed to work just fine. The DC and the AC adjustments are very similar. Instead of feeding the VTVM DC, now I'm going to be feeding it AC through this probe right here. So the first adjustment, obviously, since it was DC, was done through the DC probe, and this was just left open. Now this one can be left open, and I will now feed it AC into this probe. So I need a known source of, say, 2 volts AC, and that will be fed into this point. The ground still remains the same. So I'll put the probe down on the bench here, and I will switch this to AC volts. This is in the normal position here, and I also want to keep an eye on that 0 to make sure that 0 doesn't move. And that's really, really close. So now I will have to adjust this point right here if the AC is off. All right, so this was the DC adjustment point that gets left alone now. This is now the adjustment point for the AC scale. So I'll move this back over here, check my 0 because I've moved the meter around, and I will now feed this 2 volts AC and check the scale accuracy here. And that is extremely close. So just a little bit below the line there. If you can see that. So just a touch below the line. So we'll go here and just bump that up just a touch. And let's see if that gets me any closer. You can see just touching it moved it beyond the 2. So to your eyes it looks like it's spot on, but over here, yeah, it's very, very close, but it's just a touch over. So move that just a spot. And let's see what that's going to be like. That looks like, well, on an angle here. I look at this straight on. It still is a touch over. Finicky control. Maybe that will get it just a little bit closer. Still a touch over. I saw quite a movement there. Hopefully that didn't go too far. I'd say that's very close. Trying to look at it on the same angle as the camera here. So that's very close. And that really is the AC adjustment. That's it. It's the same as the other. You can play with the tracking. This one here tracks very well at 2. And it'll be very much like the DC adjustment, just finding the point to where it adjusts the best. And that pretty much is the AC. So very similar to DC. AC peak to peak, there is no real adjustment for that. You know, once you set this, everything else should just fall in line. Reading resistance with this meter is relatively simple. There are no internal alignment points for this. The only 2 alignment points are these 2 knobs right here. So if the meter does not read resistance correctly, there is either something wrong in the resistor chain inside this unit, or the 2 batteries in the bottom are bad or weak. So this relies upon those 2 large batteries, the 2 D cells in the bottom, in order to read resistance. I'll give you a quick example of how to set this up. This meter is surprisingly accurate in the resistance setting here. So we'll read low ohms. So that relies upon these jacks on the front here. Now we can completely ignore these 2 down here. So the very first thing I want to do is, of course, move this to ohms. That's completely normal. It should do that. I want to zero this out. Now I'll grab something metal and I'll show you why here. So a lot of people think shorting the probes is absolutely fine to set the resistance, right? Well, if I squeeze the probes, look what happens to the 0. It goes down. If I let them go a little bit. So I'll give you an example here. I'll zoom in just a little closer. So I'll squeeze them. See that? So this is a very finicky setting because this is a low ohms meter. So we need to really make sure that the 0 is good. So at this point, what I want to do is take something metal and poke the probes into something metal and, you know, really grind it in there and set the 0 up that way. And that way I'll get the most accurate 0 I can get. Now with the probes open, I need to set the infinity line, which is this knob right here. So if I move around here, it's actually very close. So this moves the needle at the top end, as you can see here. So I'll set the infinity line right onto the last line there, just before it says INF for infinity. And I'll recheck the 0 again because they do interact, right? And that's very close. So now, this is on the low ohm setting, so I'll grab a resistor here. What do I have? I have a 27 ohm resistor. That works. So here's 27 ohms. So that would be 20. So 200 would be 20 and 300 would be 30 ohms. So we're looking to be closer to the 30 mark, right? So 20, 22, 24, 26, 28, and 30. So we should be, you know, roughly around the 3rd line back. Okay, so let's see what happens here. And there it is. Look at how accurate that is. right? Right between the two. Not bad. So right between 26 and 28. So works very well. This is surprisingly accurate in the ohms. So if I wanted to say not move this switch and have this read say 10, 20, 30 ohms, 40 ohms, 50 ohms, I would move this down to the regular ohms, and then of course I would re-zero everything again because now I've moved to a different jack. So again, as you can see, it's moved the zero just a little bit. And I'll check the infinity. The infinity will probably be close. And it has moved a bit, again, because they interact, right? So a lot of the times you'll hear the term interlock, and that's basically what they're doing. There's a bit of interlock between the two. So that's very close. So now it should be just below the 30 mark right there. So I put the resistor down and it just absolutely disappeared on me. There it is. So, okay. And look at that. Perfect. So surprisingly accurate, this old thing. It's, you know, with, again, no alignment points. And of course, you know what, you can change the scales just by moving this around. So this could be, you know, 100 ohms, 200, 300, 400, 500 ohms, or 1K, 2K, 3K, 4K, 5K, 100K, 200K, 300K, 400K, 500K, and so on, right? You know, 1 meg up here. And this tests resistors very nicely. Caps is much the same. So if I wanted to test capacitance, leave this in the same area, move this over to capacitance, and this needs to be zeroed again. So zero that out, pinch the probe leads together, zero this out. And actually, I have a 0.047 I'll check here. So I'll move this up to here and I'll zero it where I would check a 0.047. Okay, so I'll just put that there, zero that out, open it, set this one to infinity again. And check the zero line. And that's close. So now I'll grab a 0.047. And now this is divide by 10. So you see where it says 0.5 and 0.4. So 0.5 divide by 10 would be 0.05. So it should be just below 0.5 or 50. It should be just below that 50 line right there on the red scale. All right, so I'll put this on here. Trying to make good connection. I had to press this against the mat down here, so look at that. Isn't that great? I'm very impressed with this meter. So reads capacitors very well. Again, you know, 0.047. You can see that. 473. The very last portion of the alignment is the milliamp adjustment. So that's that position right there. A current source is needed and will be applied to these two upper jacks right here. The AC is completely disconnected from this meter and the unit is off. So you can see the unit's off. Now it's very important to disconnect the AC and safely discharge the caps in the circuit, because if you lean this forward, hear that click? Just the weight of the unit will turn the switch on, so definitely make sure it's disconnected from any AC source. The adjustment point on the back is that nichrome resistor that you see right down there. I'll zoom you into that and move this over just a touch so that you can see that. So you can see the hair fine wire that's on that nichrome resistor. So you have to be very careful not to drag your fingernail across that or you'll open the nichrome wire. This here is the adjustment. A lot of the times it's glued with some red glue right down in the bottom. That glue has to be freed off in order for this to be adjusted, and this will slide back and forth, so this little finger will move back and forth on this nichrome wire. Now this is a very touchy adjustment and you have to be super careful. If you break that nichrome wire, you're going to have a bad day. So just be very, very careful. If it's sticky or it's stuck, don't force anything. You know, be very careful around that. You can see how fine the wire is. I'll grab something to point with here. You can see just how fine that wire is right there. And you can actually even see the little winds here. And then it's tied on this terminal right here, right? So this will get slid back and forth to adjust the scale. Now it's relatively in adjustment here. I'll see if it needs to be, you know, fine adjusted at all here, and if so, I will address that with you here in a moment. So again, I will apply my current source to the unit here, put this here and here. So the current source is plugged into these two upper jacks. Move this over here so you can see. Now I found that the best adjustment place is around 2 milliamps on this. So I'll turn this on and give it 2 milliamps. And you can see that's really close. So I don't know if you can see how close that is. Very close to 2 milliamps, right? And I'll move this down to 1 milliamp now and show you that. Hopefully you can see that. Pretty close. Now, moving that adjustment on the back will fine tune that. So if you want to move this around a little bit, if you're going to get very picky, this will get very accurate on this lower scale, so you can actually spend the time to adjust that. But you can move that around a little bit, and I'll zoom on in just a little closer so you can see that. So you can move it around just a little bit. This is so incredibly close that you know, no adjustment is really needed at this point now. So, and it should track very close on that scale. So 3, 2.52, 1.51, 0.5 milliamps, and you know, so on. And that really is the last portion of the alignment. The meter turned out very, very well. It is very accurate for what it is, and you'll see this in use on the bench here. I'll be using this in future alignments. It's nice to use on camera because the meter itself is so incredibly big, and I can see it, and you know, so can the neighbors down the road, right? And that's that incredibly big. So all in all, project successful. I'm very happy with the way this meter is performing. Many more restorations and repair videos coming in the near future, so if you're enjoying this, definitely subscribe and let me know that you enjoyed the video by giving it a thumbs up. I have an ongoing electronics course where I share many of my own personal electronic creations. You may want to check that out. It's a very busy place. There's over 220 videos there right now that are not on this platform. Great videos for you to learn from and many projects for you to build. Check it out. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. So if you click on that pinned link, it'll take you right there and you can check it out. All right, until next time, take care. Bye for now.